Okay, so let's look over this review. Again, when you're multiplying, you are creating new units. So it really, you can just basically ignore the decimals if you want. You don't even have to pay attention at all. So 9 times 7 is 63. So put a 3, bring over the 6. 9 times 6 is 54. Add the 6 is 60. Put a 0 to hold your place. 4 times 7 is 28. So, and then bring your 2. 6 times 4 is 24. 25, 26. And then add. And then at this point, you do have to pay attention to your place value. So I had 1, 2, 3 to begin with. So I'm going to have 1, 2, 3 in the end. And that's because this guy is in hundredths. This guy is in tenths. So your final unit is going to be a new unit of thousandths. And so that should make sense. And we'll double check our answers over here. Let's do lattice next, and then we'll come and do this one. So with lattice, I have 0.67 and 4.9. I'm going to make my little diagonals. All right, so this is 28. 7 times 6 is 24. This is what, 54, and this is 63. I'm going to add down here. So what is that? 18. Regroup. I get 10. I get 2. I regroup. I get 3. All right. And then, so let's see how this works. So if I take my right one and it goes kind of towards the other dot, so I'm going to go all the way, and this dot's going to come down. They're going to bump into each other, and they're going to go down this diagonal right there. The other thing is just use common sense. This is about 5 times what, 70 cents, right? So if you had 5 times 70 cents, if you think about that, you know, that's what, $3.50. So 3 point something seems to make sense. All right, let's do partial products. So I'm going to have 0.67 times 4.9. All right, so let's think about what this is. I have 0.9 times 0.07, because that's really 7/100ths, and I have 0.9 times 0.6, because that's really 6/10ths. And then the whole number, I have 4, is really times 0.07, 7/100ths, and this 4 is really times my 0.6, or 6/10ths. All right, so then again, you still have to know the decimal rule as far as where to put your place values at. So 9 times 7 is 63, but I would need 1, 2, 3 place values. So I need a decimal and a 0 there because I need 3 place values. 9 times 6 is 54, but I need 2 place values. And again, I need to line up my place values. So I'm going to line up all of those. 4 times 7 is 28, but I need 2 place values. So it's 28 in the hundredths position, 28 hundredths. And then 4 times 6 is 24, but I only need 1 decimal place there. So it's going to be 2.4. And again, when you add, you need common units. So when I add, I need to line these up. And again, if you want to put some zeros to help you out, totally fine. But you need to add your thousandths. You need to add your hundredths. Need to regroup there. And then I get what? 10, 12. I need to regroup. I get 3. And the decimal comes down, but that's so that everything stays in its place value. So it's not like the decimal coming down is magic. It's just that you need your thousandths to stay thousandths, hundredths to stay hundredths, tenths to stay tenths, and ones to be ones. So you need that to be right where it's at. Okay? All right, let's look at the grid. I went ahead and kind of started this a little bit to save time, but I counted out 10, and that unit of 10 is going to be my 1 linear unit. Okay, so if I take 10 times 10, right, a 10 by 10 grid, which would be 100 little individual things, is going to be my 1 square unit. Because it's going to be 1 by 1, and that gives you 1 square unit. So I counted out 10 and then 0.6, so this is my 1, and here's my 0.6, and I counted out 10 and a distance of 4.4. And again, remember, I'm not counting boxes. I'm counting the length here, just linear. All right, so now I'm going to go ahead and make my area, because one definition of area or multiplication is area. So I'm going to go across my ones here. All right, so 1 times 1 is 100. That's my 1. It's a flat, but it's 1 square unit of area. So this is worth 1. And then again, if I can get 10, then I would make another 1. So I have longs here, so I have 0.6 and 0.4. So this is 6 longs and 4 longs. Together that would make a flat, which again is 1 square unit. All right, and again, that's kind of these guys. That should get skinnier there. All right, so then so far I have 2 full units. Okay, so now my longs are going to be my 0.1s. So let me see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be a long. And then let's see. 1, 2, 3, 4, 5, 6, 7, 8. I think that, is that right? 4, 5, 6, 7, 8, 9, 10. Okay, so this is going to be another. So this is going to end up being 0.1 and 0.1. And then down here I have these 4. And so those are going to be my 400ths, okay? And we're not doing fractions here, but I can talk about that in a second. So I have 2 flats, which are 1 square unit. And then I have 2 sets of longs, which would be 2 tenths. And then I have 400ths. If you think of fractions on this one, I have 2 wholes. And then even if we don't put these in longs, let's just count the squares and the little squares. This is 6 by 4. There's 24 little squares, and it takes 100 to make a whole. So do you see how that's 2 and 24 hundredths, like if I write it in fraction form? So it's going to be the same number. All right, let's look at the next page. Okay, so here we're going to write a story problem, solve without a calculator, don't round, do fractional work. Okay, so again, we talked a little bit about this in class. Adding and subtracting are combining or taking away. All right, so again, money is always good. Weight, we tend to do decimals, things like that. With fractions, you could do cooking. You could do, like, there were 6 1/3 pieces of pizza, or 6 1/3 pizzas, sorry, not pieces, pizzas. We ate 4 3/4 of the pizza, how much pizza was left. But again, units have to match on these, okay? And again, so here I might say I have $12.25 and I spend $6.88 on shampoo. How much money do I have left now? Okay. And again, remember, you do line up the decimal point. You need a CD, either common denominator or common decimal, because you need common units. So again, if you want to do the standard algorithm, you would ungroup. What is that? 7. You would ungroup. That would be 3. And then you could ungroup, and that's 5. If you didn't want to do the standard algorithm, what you could do is add on, right? So 688, if you start at, let me draw a number line. If I'm at 688, what is that? 12 cents would get me up to 7. And then what would I need? Another 5 would get me up to 12. And another 25 cents would get me up to my 12.25. And so if I added 5 and then let's see, 25 cents and 12 cents make 37 cents, I'd still get $5.37, okay? All right, so with this one, again, I could say, let's see, I had 6 1/3 cups of flour, and I used 4 3/4 cups of flour. So again, units have to match even in the story problem. So I had 6 1/3 cups of flour. I used 4 3/4 cups of flour. How much flour is left? So this is a takeaway problem here. Let's see, I had 6 flour. How many cups of flour do I have left? So we could have a join story problem, or a compare story problem, or a separate story problem, just like we did with whole numbers. All right, so again, to subtract this, I could do the standard algorithm where I ungroup. I'm going to get a common denominator, so times 4 times 4, and then let's see, times 3 times 3. And I don't know, with subtracting, I kind of like to decompose. So I actually might make this a 5 and make this a 12/12 instead and leave my 4/12 there. And then I have what? The minus the 4 and the minus the 9/12. Those are both getting taken away. So let's see, what is that? 5 minus 4 is 1. 12 minus 9 is what? 3/12. And then I still have this positive. These are all positives over here. So positive 4/12. So that's what? 1 and 7/12. And again, that would be cups of flour that I would have left. I could just do normal and ungroup. So I could have 6 and 4/12 minus 4 and 9/12. Again, add and subtract, you need common units in your story problem and also when you do the math. So I could ungroup, and let's see, 12 plus that is what? 16. 16 minus 9 is 7, and then I get my 1 from that. I could use inches, like 6 1/3 inches minus, like I have 6 1/3 inches of ribbon. I use 4 3/4 inches of ribbon. How many inches of ribbon do I have left? And that would work nicely because 12s play nicely with 3 and 4. So then you would have 1 and then 7/12 of an inch. So that actually makes sense for inches since we do cut them in 12. So that might work. All right, here, again, multiplying is usually groups. It can be area. So you could do, I have 1.48 yards by 4.2 yards. How many square yards is that? Something like that. But it also can be pounds and money and things like that. So it could be that I buy 1.48 pounds. Let's see. I buy 1.48 pounds of lunch meat at $4.20 per pound. How much does the lunch meat cost me? So I could do something like that. And then again, just multiply like normal. So again, you can just leave the decimals off if you want to do the standard algorithm, or if you want to do lattice. You don't even have to do the little bumping in trick. You can just do like thinking about it here. Do you guys see how this is 4 times about 1.5? I know my answer is around 6 because 4 times 1.5 would be all of it plus half. So I know where it's going to be 6 point something. All right, but I can do my little lattice thing here. That's what? 32. 8 times 2 is 16. What is that? 16. That's 8. This is 0, 4, and that's what? 0, 2. So 6, this is what? 11. Regroup, I get 10, 12, get a 6 there, okay? And I could just use logic to know at 6 point whatever. If I use the little bump in trick, this one goes until it lines up with the one up here. This one bumps in and it goes down that diagonal right there, okay? The other thing is count place values. I have 1, 2, 3 place values, so I know I'm going to have 1, 2, 3. And that should make sense because if you have something in the hundredths and something in the tenths, when you multiply, you're going to get something in the thousandths, so that makes sense. All right, I could do like 148% or even 420%. Like a store buys an item for $1.48 and they have, they use 420% of it for their price. How much are they going to price the item at? Something like that. All right, let's look at this one. Again, I could use groups or like tripling a recipe. So I might actually commute this and say that I am going to make 3.5 batches of cookies, and each recipe calls for 2 2/3 cups of flour, and then something about like how much flour do I need to make all these batches, so how much flour do I need? All right, and then we'll pick up with the rest of that in the next video.